We all know Jeff Bezos as the founder of Amazon and pioneer of the e-commerce industry. But one thing most of you might not know is that Jeff Bezos is also the founder of Blue Origin, a privately funded space flight company that was initiated to make space travel cheaper and accessible to the masses. Ever since its launch, they have made some massive progress, but their biggest upgrade is just around the corner, as they're about to launch their next-gen rocket engine, the BE-4 engine. Stick around to the end as we uncover the details about BE-4. If you're new here, then consider subscribing to TechWave as we frequently upload videos like this one. Now, Blue Origin was founded in 2000 as a passion project of Jeff Bezos' childhood. Bezos wanted to change the dynamics of space tourism by creating reusable spacecraft that were cost-effective and reliable. They planned to do so by manufacturing rockets that use a vertical takeoff and landing mechanism. In a session while talking about Blue Origin, Bezos said, "It's called Blue Origin because this is the blue planet, and this is the planet that we have to save." This explains his vision with Blue Origin, as he wants to make the Earth a blue planet by making space accessible to all. Even though Blue Origin was founded in 2000, 2 years before Elon Musk's SpaceX, we can tell that Blue Origin hasn't made much progress as compared to SpaceX. When compared with Blue Origin, SpaceX has been more successful as they've just received their lunar lander contract from NASA. Here, a critical question arises. What has Blue Origin been doing wrong lately? They clearly started before them, had a stronger mission, had an abundance of funds, and are backed by the Amazon chairperson. What went wrong? According to Blue Origin's former employee communications head, Ali Abrams, Blue Origin is facing an immense amount of technical debt, engineering challenges that are hindering its growth. In an article, she wrote, "Technical debt is a problem most companies have, but at Blue, it's just on an incredible scale," Abrams said. It really failed to transition from an R&D company to a production company. Moreover, they've also been around the headlines for all the wrong reasons, which is why their growth has been slow over the years as compared to SpaceX. Blue Origin can, however, redeem itself through the launch of its highly anticipated BE-4 rocket engine. BE-4 is the most powerful liquefied natural gas or LNG-fueled rocket engine that uses an oxygen-rich staged combustion cycle to produce 2,400 meganewtons of thrust at sea level. LNG was chosen to fuel the engine because it's highly efficient, low cost, and widely available. Blue Origin started working on the BE-4 rocket engine in 2011, but announced it in 2014. Now, in the beginning, it was planned that Blue Origin would be exclusively manufacturing this engine for their first orbital spacecraft, New Glenn. But later on in 2014, Blue Origin partnered up with United Launch Alliance, ULA. In this partnership, Blue Origin would be manufacturing the BE-4 engine to power ULA's Vulcan Centaur. It was a bold move by ULA, as they trusted a new entrant in the market with the manufacturing of their launch vehicle's engine. They were convinced that the technology used by Blue Origin in manufacturing the BE-4 engine would promise them high-performance, low-cost, and highly efficient engines with power output similar to a space shuttle. Blue Origin was positive that the engine would be ready for delivery by 2017. However, due to technical difficulties, it had to be delayed until late 2022. The launch of Blue Origin's New Glenn is highly dependent upon the success of BE-4 rocket engines, as the launch vehicle would have 7 of these engines to generate enough power. These engines would assist the launch vehicle in landing, as Blue Origin plans to make the first stage of New Glenn completely reusable. Till now, we have an idea of Blue Origin's BE-4 engine and why its success is important to the spacecraft company. Let's discuss in depth what are the features of the engine and how it claims to be efficient, reliable, and cost-effective. Number 1. LNG propellant. LNG propellant is the most significant component of the BE-4 rocket engine. This propellant is distinctive from other propellants as it utilizes LNG to power the engine instead of the regular kerosene ones. Blue Origin went with the LNG propellant because LNG is budget-friendly, more efficient, and readily available as compared to kerosene. Moreover, LNG can also self-pressurize the tank, which eliminates the need for complex plumbing to repressurize the tank with Earth's scarce reserves of helium gas. LNG would also allow for clean combustion as compared to kerosene, which in return would make the engine more reusable. Number 2. Simplified design. Blue Origin mentioned from the beginning that BE-4 is a simplified design that was designed from the beginning as a medium-performing version of a high-performing engine. What they mean by this is that they could have made BE-4 a very high-performance engine, but they chose to slightly limit the power to lower the development risks. They kept the engine at an ideal power, which didn't interfere with its performance or reusability. In short, they made the BE-4 engine compatible enough for future launches but didn't go overboard with the performance capability. They did so because the increased power would call for more intense testing and delays, which in return would delay the BE-4's launch for future years. Number 3. Increased power. The third and final key feature of the BE-4 engine is the increased power. Blue Origin previously manufactured BE-3, which is used to power the New Shepard. The BE-3 engine was a success, as it could power the New Shepard perfectly and land a smooth landing. However, the BE-3 isn't powerful enough for larger launch vehicles, which is why Blue Origin sought the need for a BE-4. The BE-4 could generate 5 times more energy than the BE-3, and is the most powerful liquefied nitrogen gas engine manufactured. Thanks to the propellant design and oxygen-rich combustion cycle, BE-4 could be reused for up to 100 trips. The BE-4 engine has been in development for more than 10 years. What updates do we have on the engine's progress? Let's discuss them in detail. Now, due to the recent controversies relating to Blue Origin and its slow growth, Jeff Bezos stepped down as CEO of Amazon in 2021 and shifted his entire focus towards Blue Origin. With Bezos playing an integral part in the spacecraft company, we've seen considerable improvements in the right steps. When it comes to progress updates, Blue Origin doesn't release much information. However, through Tori Bruno, the CEO of ULA, we've been able to find out some recent updates on the development of the BE-4 engine. In a series of tweets, Bruno answered some of the key questions of space enthusiasts. He also uploaded a picture of the BE-4 engine with a Blue Origin employee standing next to it for size comparison. In another tweet the next day, Bruno posted another picture of the second BE-4 engine for the ULA's Vulcan. The response to his tweet session was amazing, so he decided to share a picture of both BE-4 engines being manufactured in the factory. Along with these pictures, Bruno also answered some questions by the space enthusiasts by giving updates on the progress of the BE-4 engine. He was positive that Vulcan Centaur's launch would happen as scheduled. Well, that's all for today. What do you think? Will Bezos succeed in his mission of transforming Earth into a blue planet? Let us know in the comment section below. And if you enjoyed this video, then give this video a thumbs up and subscribe to TechWave for more videos like this. Thanks for watching, and we hope to see you next time.